All right, next problem is number 25 that was asked for. So 25 is a little different. We'll graph it in a minute. They actually give us an equation. So we've got 4x minus y squared equals 2y plus 13. All right, so right now it's in the form that does not tell us the vertex or the A. So let's go ahead and work on completing the square. We've got the quadratic term here, the linear term, so let's move everything to this side except for the x. So we've got 4x equals y squared plus 2y plus, move that over just a smidge, plus 13. All right, and then we're going to take this stuff here and complete the square with these two so we can get a nice perfect square trinomial in here. So 2 divided by 2 is 1, squared is 1. And if I'm going to add 1 to this side, I better subtract 1 so that I can stay an equation. So this gives us a perfect square trinomial, y plus 1 quantity squared plus 12. And so we can then divide everything by 4. X equals, this will be 1/4 y plus 1 quantity squared plus 3. So we can tell right off the bat which direction we're opening. So we're going to open to the left, pardon me, to the right. And we've got our H and K movement in here. And I don't think I was really clear about this, or I might have even said it wrong. This, whatever's next to your Y is your K movement. And then this guy here is going to be your H movement. So we've got a vertex at over 3 and down 1. And our A value is 1/4. So let's go ahead and graph that guy. Bring this back. We've got our vertex at over 3, 1, 2, 3, down 1. And we know that we're opening to the right. A is equal to 1/4. A equals 1/4. So that means if we're doing 1/4A as our distance from the directrix to the vertex and the focus to the vertex. So we can do 1/4 times 1/4. This is probably where things might have gotten a little tricky for you. So that's equal to 1. So our distance from, here's our vertex to our focus is 1, and our distance from our vertex to the directrix is also 1. All right, so the only thing left to do is the length of the latus rectum, so that'll tell us how wide to open our parabola. So the latus rectum length is 1/2A, and A is 1/4. So we've got 1 over, let's see, I'll do it down here, 1/2, and A is 1/4. So we can reduce this fraction, 1/2. And remember how to divide fractions, that makes this 2. So we can take our vertex, go up 2 from there, pardon me, focus, 2 from there, and 2 from there. Does it help? It might help if I do V and F, might help you out a little bit. So that's the latus rectum, and then we can connect our vertex to the endpoints of the latus rectum. And there is our parabola. So number 25, there you go.